Okay folks, this is a continuation of your introduction to arithmetic sequences, exercise 4D this is, and in here I'm going to see if you can help you construct and use rules for finding the nth term of an arithmetic sequence. I'll explain what that means shortly, and also graphing sequences. So we're going to find a rule for finding the nth term of an arithmetic sequence. For instance, finding the 1000th term of a sequence. Now you already know that if you use your ordinary 4-function calculator you can find the 1000th term, but you'll have to press enter 1000 times. Or you could go into your graphics calculator, put the recurrence relation in, and then scroll down to the 1000th term. But what if we had a rule that would take us directly to what the 1000th term actually is? And that's what this is all about. So we're still dealing with recurrence relations, but we're just adding a new rule, which is at the bottom of the screen. Tn equals a plus n minus 1 times d, while a is the first term, and d is the difference between each of the terms, which is going to be an addition or a subtraction, isn't it, on an arithmetic sequence. So if you wanted to find T1000, for instance, you put in the first given term for A, and then you are going to add 1000 minus 1, which is 999, times the difference, which makes sense. You've got the first term plus 999 of the following terms. That will obviously give you the 1000th term. So if you have a sequence that begins with 100 and goes down in 15s, you're going to find any term by putting in 100 plus 1 minus that position times negative 15. Let's see if you get all that. So we've got a couple of sequences at the top here, 8, 5, 2, negative 1. Now I hope that you can see that A is 8, and D is going down, so D is minus 3. What about the next one? First term is, and they're going up or going down? Negative 9, negative 4, 1, 6. Always check all numbers in the given sequence, because it could not be arithmetic if they're not all the same. But this time the difference is 5, definitely. Okay, you've given an arithmetic sequence now, 2 of them. Could you write up that rule for finding the nth term? Now what you do is you write t little n equals a, in this case is 146, plus, and you put brackets n minus 1, and then you're going to be multiplying by the difference, which I think is fairly obviously 50. Second one, Tn again, that's what you do each time, equals 8. You still put a plus there, still put n minus 1 there, times the difference. Now they're going down in 5s, so times negative 5. So in those examples, if you're given a sequence, you can identify the first term and the common difference and write a general rule for finding any term in that sequence, whether you want the 10th, the 100th, the 1000th, the millionth, or whatever. If you're given a sequence as a recurrence relation, as you are in these two examples at the top here, you can still find the rule for the nth term. And so you're still going to write Tn equals, well, T1 is minus 8, so A is minus 8, plus n minus 1, and the difference is, you can see from the end there, is 3. Second one, Tn, this is what you do every time to write the rule, negative 1 plus n minus 1, always n minus 1, times negative 6. Let's use the rule now. Find T26, find the 26th term of the sequence here. Now I suggest what you do is you first of all write down what A and D are. So A is negative 19, D Looks like they're going down, so in fours, is it? Yep, minus 4. Now, you write first of all this T26, well, the 26th term, we know what n is now, a minus 19 plus, now what's n minus 1? Well, if we're finding the 26th term, then n minus 1 is 25 times your difference of minus 4. And we can work that out. First of all, clear the brackets. Minus 19, 25 times negative 4 is negative 100. That's minus 100. So T26 of that sequence is minus 119. And set out your answers like that. One more example. What do we do first? We write down A and D. A is 100. 7 is being subtracted, so D is minus 7. We want the 20th term, so T20 equals 100 plus, well, n minus 1 is 19 times negative 7. 7 20s are 140, and 7 less than that is 133. So we've got 100 minus 133 because that is negative, and that will give you a net value of minus 33. Alright, that's some examples. Just quickly about graphing them. You've already put recurrence relation into your graphics calculator. Well, if you want to actually see what it looks like, you press Window and you've got 3 things to set. Depends which values of the sequence you want to plot, but whatever it is, you want to make sure that n-min and n-max shows you whether you want the first and the 15th, first up to the 15th or whatever. X-min and X-max you have to put in the range of values for the horizontal axis, so you must have some idea what it's going to be. Y-min and Y-max for values of Tn, so for those terms you have to cope with the values. Now you might find that you could also do that with Zoom 9. Check that out for yourself. But anyway, you should finish up with the graph looking like that. There you go then. You can now construct and use rules for the nth term of an arithmetic sequence and hopefully graph them as well. Try to complete all the questions in exercise, that should say exercise 4D, sorry, and whatever page it's on, I don't know. Okay, well done, thank you.